Hi, in this lesson I would like to introduce the earthquake engineering concept of a captive column. In past earthquakes, the interaction between architectural features and the building structural system has shown to play an important role in the building's overall performance, and in some cases, like shown in the picture here, the interaction has led to significant damage to the building structure itself, and in some cases has led to collapse. I'd like to start with the definition of what is a captive column. When an engineer designs a frame building, particularly that made of reinforced concrete, consisting of columns and beams, it's very important to consider how the architectural elements such as partition walls, or header courses interact with the building structure. As seen in this photo, the block masonry walls that are placed to mid-height of the concrete columns have created a stiff and strong element that has restrained the movement of the concrete columns and the structural frame. The designer of the building would have intended for the frame to deflect evenly between every floor. However, with the introduction of this masonry infill wall and the corresponding strength and stiffness, now this deformation has to occur over a much shorter height of the column, and the designer did not account for this, and as you can see, the column performance has been compromised as a result. So a possible way to mitigate or avoid this type of behavior is to isolate the infill masonry or block partition by leaving a gap in between the block partition and the building column. Of course, there are other considerations such as how to brace this wall for out-of-plane forces, including either wind or earthquake loads. In order to successfully do this, all members of the project team should think about the architectural elements and the building structure, particularly at the intersection of them, and talk through how the connections can be made that do not compromise the earthquake performance of the building.